to study the environment around the Earth, in space, this Earth-space environment. The Earth has a magnetic field, the same magnetic field that sailors use to point to the north. Also forms a cocoon in space, and this cocoon protects the Earth environment from what arrives from space. In space, there are serious threats. The sun emits a constant solar wind made of electrons and protons that flow through the solar system, reaching also the Earth. And within this solar wind, there are disturbances, important disturbances, solar eruption, high-energy particle emitted. And on top of that, there are cosmic rays. The cosmic rays comes from outside our solar system, from the universe. All these pose serious threats for our society. Our life on the planet is protected by the magnetic field of the Earth and also by the atmosphere. However, this protection is not perfect. When you look at the technology that we have, especially the power lines, they are at risk of being disrupted by these events happening in space. And then, of course, the space activities, spacecrafts, satellites, humans in space are a threat. So it's very important to study these processes to fully understand and have a correct and reliable prediction of what happens in the space environment around the Earth. We need to treat the electrons. And the problem is that the electrons are very much lighter than the ions. The ions are about 2,000 times heavier than the electrons. So electrons move faster on smaller scales and especially on very small domains. So we need to be able to treat small things and big things, and this is very difficult to do, and that's the first milestone to reach. The second is the fact that because we are resolving all these different scales down to the small electron scale, we have a tremendous amount of information to deal with. It's so much information that we cannot look at this with our own mind. It's too much to look at. And therefore we need machine learning and artificial intelligence to analyze the data and tell us what the data means. And that's a second milestone that we need to reach within Deep Sea. Our goal is to be able to understand the Earth space environment, make prediction of what is going to happen. And to do that, we need to bring together the competence in astrophysics, in space science, and those in supercomputing, computer science. The new supercomputers that are coming up will allow us to do the physics that we want, but this is a big challenge because the new supercomputers are so-called heterogeneous. Heterogeneous means they are made of different type of parts, CPU, computing units, and GPU, graphical units, that can be used together, and different aspects of the simulation will better run on the CPU and others will better run on the GPU. And finding out which parts to put in the different parts of the machine, how to coordinate the whole activity. The simulation becomes like a collective, which individual parts have different tasks that are best suited for the different parts of the machine. That's a big challenge that needs a person to understand what is happening, the physics that's happening, and the software that is running, and the hardware where the software runs on. And this is what Deep Sea can do, because it has all the right people to cover all these different aspects of this challenge and brings to a successful conclusion, reaching our goal of predicting what's going to happen in space using all these new supercomputing machines with this heterogeneous feature.